Once again, welcome to A-Level Physics. This is Cambridge A-Level. We're going to cover 4.2 in the syllabus called Equivalent of Forces. Let's just review what we have learned in our previous video, in our previous lesson. We started off with Newton's first law. An object at rest remains at rest. An object in motion continues in motion with the same speed and the same direction unless acted upon by an unbalanced force. Right? So this one tells us if there's no resultant force, the object, if it's resting, is stationary, it will remain stationary. If it's moving, it will continue with the same velocity. It means it has no resultant force. And we look at forces in equilibrium at a point, or if all the forces pass through the center of gravity, what are the conditions required for equilibrium? Right? We say no resultant force, or the force will form a closed triangle. Right? We take in order waves and T2, and we go T1. Or we can draw the diagram itself. Then we define center of gravity of a body is a point where the weight of the body is considered to act. Right? And then some example for meter rule is the center of the ruler, or if it's rectangular shape, is the where the diagonal intersect. That's the center of gravity C or G. Center of mass is the same. Then we come to another condition. We say that forces can cause rotation about turning point called the pivot. So if you apply the force not at the center of gravity or lower, then we find that there's a possibility that this block of wood or wooden block will rotate about this point called a pivot, and it will topple over or stay in a new equilibrium. And we call this a clockwise moment. Then we define moment of a force times perpendicular distance from line of action of the force to the point. So pivot, must decide where is the pivot, where's the force, there's a line of action, and a perpendicular distance. That's your pivot. That's where you rotate, either going down or going up. There's your force, and then parallel to the force, the line is called the line of action of the force, and that is a perpendicular distance. So moment of force is force times perpendicular distance. And if it is at an angle, we say that we just use resolve the force, right, a particular force, into its component, perpendicular component to the lever arm, and parallel to lever arm. And this one we don't bother because it causes stretching. You just pull it out, make it long, make lever arm longer. So we say we take the perpendicular force or perpendicular component of the force times the lever arm. Easier. Then we come to what is clockwise and what is anti-clockwise. We follow the minute hand as clockwise. And if you turn the other way, anti-clockwise. And we state the principle of moment. Right? We summarize it. For a body in equilibrium, balance, we call it balance, the sum of the clockwise moment is equal to the sum of the anti-clockwise moment about any point. If we take any point, it must work. Sum of clockwise moment equals the sum of anti-clockwise moment. That is our short form. And we state what is a couple. Two equal forces in opposite direction, line of action are different. The couple cause rotation. Okay. Then finally we define torque. Torque for Cambridge is applied to couple. But for American textbook, the torque can apply to moment. Okay, so we have derived the torque force and perpendicular distance. We take one force and the perpendicular distance between the force. Okay, state and apply the principle of moment. We have stated that earlier. So we'll do some workout example. Understand that when there is no resultant force and no resultant torque, the system is in equilibrium. Use vector triangle to represent coplanar forces in equilibrium. Next one we have done earlier. So we will state the conditions for equilibrium: no resultant force, no resultant torque, or moment, or the sum of moment equals 0, or sum of clockwise moment equals sum of anticlockwise moment. That's the other alternative. Sum of clockwise moment about any point, so sum of anticlockwise moment about the same point. Right? This first condition, no resultant force, ensures that the body does not accelerate. That means it is stationary, or if we move with constant velocity, it doesn't accelerate. Okay, second condition, ensure no resultant torque. Second condition ensures that there is no rotation. If it's not rotating, or if it rotates with constant speed. The speed doesn't increase with time. Or we call it angular acceleration. Okay, what's the magnitude of W? Right, this is an example. To find this W, that distance is given. So we can draw the forces from the center of gravity. From the center of gravity for this object, the distance is given. So we take moment about pivot. Taking moment about pivot, sum of clockwise equals the sum of anti-clockwise moment. 300 times 1.0, 450 times 1.5 equals to W times 1.5. We can use a calculator and calculate out. What's the reaction at the pivot? Show its direction. Right? All these forces are pushing it down. So the reaction at pivot must be pushing up to balance it. This is the first condition. The second condition that we are using. How is the reaction force of the pivot on the rod, keep it in equilibrium. Sum of forces outward equals sum of forces downwards. So R is outwards equals to all these downward forces. Add them up, 1,400 Newton. Right? This one came out in one of the paper 3 experiment in the paper 3 exam, one of the exam. Right? Where this is your Newton meter or spring balance. That's your meter rule. Right? You want to change, this is the constant mass, and we want to change that distance and read this value. You can draw the forces acting as a center of gravity. That dotted mass or an angle will act as a weight W. There's another force pulling it up in the string, tension. Right? F is measured by the spring balance. F is here. Mg is the weight of the ruler, weight of the load. There is a load there we add on the meter rule. There's your F, tension in the string measured by the spring balance. Right? So we are interested in this experiment, how does F changes with D? There's your F. There's a distance D. That means you're going to change this mass. Okay. That's the equation that is given in the experiment sheet, paper 3. But we can derive it. These are forces in a plane. Right? We can take sum of clockwise moment equals to sum of anti-clockwise moment. X is the tension at A of the string at A. F is the tension in the string at B. Right? That's your F. It's a W. Mg is the weight of the meter rule at center of gravity. L is the length of the rod AB or meter rule. Right? So center of gravity is at half the length of the meter rule. And that distance there is L minus D. Taking moment about A, we are not interested in X, interested in F, changes with W. So sum of anti-clockwise moment equals sum of clockwise moment. Right? F times L. That's your anti-clockwise moment. Clockwise moment is W times LD, that distance, plus your S force, mg, times your half L. Right? Subtracting F, we divide all by L, we get the answer. Right? By L, we got W. W is taken to that side there. And then we got our minus W, L. Right? We divide by L, the L cancel off, so we still got half mg. Okay, let's do some summarize of forces. Center of gravity, remember, point where the weight appears to act. Three known parallel forces in equilibrium are concurrent. That means no resultant force. Concurrent, that means all must pass through a point. Then we define moment of force and perpendicular distance. Couple two equal but opposite forces whose line of action are different. Top, right? For a couple, torque is just the force times the perpendicular distance between the two forces or between a couple. Then principle of moment, sum of clockwise moment equals sum of anti-clockwise moment or any point. Then we come to condition for equilibrium, no resultant force. Right? That your syllabus tends to use not moment but torque. Okay, so we can summarize what we have learned. Clockwise or anti-clockwise. Force by perpendicular component the length times the component of force perpendicular to length. Okay, so what's the answer for this one? The diagram shows a bird in flight. In which direction does the weight of the bird act? Right? You know that at the center of gravity, donkey. Diagram shows a force acting on the aeroplane. Right? This is your O-level question, just to whet your appetite. Which statement about the forces is correct? Force from the engine, lift from the wings. Right? Force from the engine, right? Which is this one, is balanced by air resistance, equal to air resistance. Lift, force from the wings, equals to weight. The answer is A. Okay, what will be the answer? A body is acted on by two equal forces, E and Q. A frictional force, F, holds the body in equilibrium. Which vector triangle would represent the relationship between the forces? Right? Remember, the three forces now form a closed triangle. This one, no. Right? This is the resultant. This one go anti-clockwise. This is the resultant. This answer. All point in one direction. Form a closed triangle. This one, no. This is the resultant. Answer C. Right? They must all point clockwise or anti-clockwise or form a closed triangle. A pendulum of mass 60 grams is attached to a string hanging from the ceiling. Show the forces acting on the board. From the center of gravity is the weight. Tension pulling up on the board by the string. T. Size of weight, we use mg. Change it to kilogram. That's 9.81. 0.59 Newton. How are the two forces related? They are equal to each other. Tension, balance your weight. That's why it stays stationary. Does the two force pass through a point? Yeah. It passes through a center of gravity. If the resultant force is zero, the particle is either stationary, not moving, or moving with uniform velocity. If it is moving, continue to move. Okay, let's try this one. Pendulum bob is held stationary by a horizontal force H. The three forces acting on the bob are shown in the diagram. The tension in the string is D. That's the tension. They're very kind to draw for you. The weight of the pendulum bob is W. Which statement is correct? So the three forces must form a closed triangle. You can either resolve it vertically. Right? Vertically, there is no resultant force. So this is alternate angle. So this is 30 degrees. So that T cos 30 must balance by W. And your H must be balanced by your T sin 30. Right? Then you can look at all the answer. No, it's wrong. This is wrong. This is wrong. Right? From here, W equals to T cos 30. That's the answer. Right? These two divide. 2 divided by 1. You get tangent. T and T cancel off. So sin 30 or cos 30 is tangent 30. H of W. Unfortunately, to one that. Right? So answer is C. We can draw the triangle of forces. If we don't want to use component, right? There's your H, there's your W, there's your T. So the angle is 30 degrees. Right? We still get the same answer. Okay, get all these equations. Okay, let's try the question. Ask the question. A hinge door is held closed in a horizontal position by a cable. That's your cable. The three forces act on the door. The weight, that's your weight of the door. The tension in the cable, they are very kind to draw for you direction. And the force H at the hinge. Force H at the hinge. Which list gives the three forces in increasing order of magnitude, means from the smaller to larger. So the three forces must pass through a point. Right? Draw on the diagram. Because we want the magnitude, so the force direction must be quite accurate. Right? W plus T plus H, that's your vector equation. Right? That's your T. That's your W. That's your H. They form a closed triangle. So we can see the smallest one is W. T is the largest one. The answer is C. Choose the correct answer. When three non-parallel forces acting on a body in equilibrium, what's the answer? A. Direction of force pass through a point. Right? What is the center of gravity? If that is the origin, this is 20. This is 10 cm. Now it's 30 cm. Right? So center of gravity will be center of this 20 is 10. Then you got y coordinate. Center of 30 is 15. Then center of 10 is 5. So x, y, z, 10, 5, 15. What's the moment of the weight about the pivot? That's your pivot. That's your weight. That's your line of action. That's the perpendicular distance L. So WL. Right? There's your pivot, there's your weight. So line of action of the force coincide. Sorry, missing. Line of action of the force coincide. Right? The weight and the line of action of the force coincide. So not perpendicular distance. So moment is F, that's perpendicular distance. So F is your W in this case. So no moment is 0. If the angle is given, is horizontal line. That's your pivot. That's your weight. That's your horizontal line. That's your length, L. Right? When we say light rod, it means there's no mass. Mass is 0. So in this case, it's just your L times the perpendicular distance. Right? You can take the force, like weight that the perpendicular distance, L cos theta. Which of the following are coupled? Right? Remember the force must, it's not the right one. Force must be the same magnitude. This is the one. Right? This one same magnitude, but the line action must be different. This one, they are in the same direction, so no. Answer is B. Equal force, line action different. A uniform rod, try a partial question. A uniform horizontal beam pivoted at right hand end, at the right hand end, is in equilibrium. A force of 60 Newton acts vertically upwards on the beam as shown. What is the weight of the beam? We want to find that. So, take a moment about the pivot. Taking a moment about pivot. Sum of anti-clockwise will sum of clockwise. This one will cause anti-clockwise. Right? That's your, sorry, this one should be clockwise against and sum of clockwise equals sum of anti-clockwise. Maybe you will change to that. Change that. Okay, so clockwise is 60, and that distance 20 plus 30. Doesn't matter, you can use the same unit. You can use cm, doesn't have to change the meter because you're interested in weight. Right? If particular, you can change the meter. And the weight is your anti-clockwise times 30. If you use cm, this must be cm. If you use meter, this must be meter. Both of them must be the same unit. W cross multiply of 60 and 30. Cancel off the 30, we still got 2, so it's 100. 60 divided by 30 times 50. So it's 100 Newton. Answer is donkey. Define torque. Okay. So answer is B. not moment of force, moment of couple. Product of force and perpendicular distance between the forces. Okay, what's your answer? Diagram shows four forces applied to a circular object. Which of the following describe the resultant force and the resultant torque on the object? Right? Resultant force is 30 plus 30 to the right. Vertical none. That is going up, is going down, so resultant force is 0. So 60 to the right. Resultant moment, this one will go, if we take the center, this one will go clockwise, this will go anti-clockwise, balance. Only this one will cause the torque, 245 forces. Right? So it will be clockwise, resultant moment clockwise, torque, okay, clockwise torque is 45 times the diameter. So A, non-zero. Okay, both of them are non-zero. What's the answer? Force is applied to the beam of length D from the pivot. This is your pivot, this is your length D. That's your beam. The force at an angle theta to a perpendicular to the beam. Right? The force at an angle of theta to the line perpendicular to the beam. Right? That's the line. And the force at an angle theta to this line perpendicular to the beam. So we just resolve this force perpendicular to the beam. The answer is C. Right? Perpendicular distance as perpendicular force, or component of this force perpendicular to the beam. The uniform plank is pivoted at its midpoint. Two weights are added to the plank. One weight on each side of the pivot in the position shown. That's your weight. That's your weight. The vertical force is applied at X to balance the plank. What's the size of the and direction of the force? Right? These two is acting downwards there. So you are going to find that force at X to balance it. Right? It will be, right? There will be an anti-clockwise moment here. This will cross the clockwise. So this one is larger. So this one will cause it to go anti-clockwise. So we want this one to go outwards there, cause it to go clockwise. Taking a moment about P, you have a sum of clockwise is 8 times 2. Right? Doesn't have to change the meter. If you want, you can change it. Sum of anti-clockwise. So anti-clockwise, because we are going to calculate the force, right? Not the moment. So anti-clockwise is just your 12 times 2. So to balance the plank, the force must be upwards at X. Right? This one is greater, anti-clockwise is greater, so you want clockwise. For a clockwise moment. So we have some of clockwise, some anti-clockwise. So it's 16. Then we got F times 2 plus 2 is 4. So it's 4F equals to 24. So F equals to 8, 24 minus 16. Right? We don't have to change the meter. We don't have to change because it's already in meter. So F is just 2 Newton. Answer is B. Okay, let's try one last one. Right, this is an old question. A heavy uniform beam of length L, that length there, heavy means it has a weight, supported by 2 vertical cords. These are your vertical cords, as shown in the diagram. What's the ratio of T1 over T2 of the tension of the cord? You want tension, this one. So at the center of gravity, G, right, middle of the rod, you have 2 uniform, so it's at the center of L. That's your weight. Okay. So we are interested the ratio of T1 against T2. Right? 3 places we can take a moment, about here, about here, about here. No point in taking any elsewhere because there are only 3 different forces. So where we take moment about center of gravity, we don't have to worry about this weight because it's not given. Okay, we want T1 over T2. So taking moment about G, counterclockwise, you can sum anti-clockwise. So T1 clockwise times your half the length. That's half the length. Let the length be L. That's half L. And T2 perpendicular distance, that one there is 2/3 L minus half L. L is half T1, right? L and L can cancel off. So 2/3 minus half, right? 2/3 is 4 over 6. Half is 3 over 6, so it's 1 over 6. So T2 times 1 over 6. So T1 over T2 cross multiply. Take the 2 out. 2 times 6, 2 divided by 6 is 1/3. So answer is A. Okay, so thank you. That's the end of the lecture. The next topic will be upthrust and pressure and density.